The Alexander L. Kielland jolted with a sudden violent shudder that sent cups sliding across tables and men grabbing for railings. The movement felt wrong immediately. North Sea platforms rolled constantly, but this was sharper, heavier, as if the structure itself had been struck from below. Alarms sounded almost at once, echoing through corridors as the floor began to tilt beneath the feet of workers who had been eating, resting, or preparing for the night. The Kielland was not a drilling rig. It was a floating accommodation platform built to house offshore workers assigned to nearby oil production installations. Constructed in the mid-1970s, it contained bunk rooms, dining halls, locker areas, showers, and recreation spaces for crews rotating through long shifts at sea. On the evening of March 27, 1980, 212 people were aboard. Most were off-duty and relaxed, unaware that the steel structure supporting them had been weakening for years. The platform floated on 5 massive hollow steel columns connected by horizontal braces designed to distribute stress from waves and wind. One of those braces carried a hidden defect dating back to construction. A small steel plate had been welded onto it to support a hydrophone used for underwater monitoring. The weld was poorly executed, introducing microscopic cracks too small to be detected during routine inspections. Over time, constant motion in the North Sea flexed that joint thousands of times. Each movement widened the crack slightly, turning a tiny flaw into a critical weakness. On the night of the disaster, strong winds and heavy seas applied the final load. The weakened brace fractured suddenly. When it failed, the structural load shifted instantly to the remaining supports, which were never designed to absorb such a sudden imbalance. One column failed, followed quickly by another. The platform lurched hard, sending furniture, lockers, and equipment sliding across floors as hallways turned into steep, slanted ramps. Inside the Kielland, confusion spread rapidly. Emergency lights flickered as the electrical system strained. Men tried to reach lifeboat stations, but found ladders impossible to climb at the growing angle. Doors jammed as the structure twisted. One lifeboat was crushed against the side of the platform before anyone could board it. Another hung uselessly when its launching mechanism failed under the stress. As the list worsened, people were thrown into the freezing sea. The water temperature allowed only minutes of survival without protective gear. Waves slammed bodies against debris as helicopters and nearby vessels rushed to the scene. Survivors clung to floating wreckage or overturned rafts, calling for help until their voices faded. Rescue crews worked through darkness and heavy seas, pulling men from the water suffering from hypothermia and injuries, but many were already beyond help. Inside the partially collapsed structure, water surged through broken openings, flooding cabins and corridors. Some workers delayed escape while trying to free injured co-workers trapped by fallen equipment. Others hesitated, believing the platform might stabilize. The Kielland had always seemed solid and dependable, and that trust cost precious seconds as the tilt grew worse. By morning, the scale of the disaster was undeniable. 123 people were dead. Families along the Norwegian coast waited for information as rescue lists were released slowly, name by name. The loss shocked the offshore industry. The platform had passed inspections and carried certification that suggested it was safe. Few could believe that such a structure could fail so completely. The investigation uncovered a chain of failures rooted in design, construction, and oversight. Metallurgical analysis traced the collapse to the cracked brace and the defective weld added during construction. The crack had grown undetected because inspections focused on visible damage rather than internal fatigue. Regulations at the time did not require detailed stress analysis for secondary structural components, and responsibility was spread across designers, builders, operators, and regulators. Survivors described how familiar spaces became deadly within minutes. Dining areas tilted so sharply that tables and chairs piled against walls. cabins flooded as seawater rushed in through openings created by the collapsing structure. Some men stayed behind to help others, losing their chance to escape. Others jumped into the sea because remaining aboard felt even more dangerous. Rescue crews later described the operation as relentless and exhausting. Survivors were found clinging to overturned lifeboats or drifting debris, their strength fading rapidly in the cold. Hypothermia set in quickly, robbing even strong swimmers of coordination. Many who survived carried lasting physical injuries and psychological trauma from the experience. The disaster exposed how confidence in certification had replaced deeper scrutiny. Engineers had assumed that braces classified as secondary could fail without threatening the entire structure. That assumption proved fatal. The hydrophone plate had been added late in construction and never subjected to independent stress analysis. Over years of service, waves, wind, and shifting loads worked silently on the flawed joint, weakening it until failure was inevitable. Families of the dead demanded accountability as hearings revealed how many layers of oversight had failed. No single person or company was solely responsible. Instead, the collapse reflected a system that allowed small risks to accumulate unnoticed. Offshore safety had relied too heavily on paperwork and too little on real-world stress behavior. The Kielland inquiry became required study material for offshore engineers, showing how catastrophic failure could begin with something almost invisible. It reinforced the reality that safety margins shrink over time when stress is constant and inspection is incomplete. Decades later, the Alexander L. Kielland remained one of the deadliest offshore accidents in history. The platform had not collapsed because of an unpredictable storm or extraordinary force. It had failed because a structure expected to endure the North Sea was never fully tested against the stresses it faced every day. A single overlooked weld turned a place of rest into a grave. Thank you for listening to Road to Ruins. Subscribe for more true stories where systems fail and people pay the price.